Okay, this is going to be your review answers. And I'm going to walk through all these. If you know these, you know the vertex form of the parabola. Should be fine on this quiz. It says a parabola is defined as the set of points in the plane that are equidistant from a fixed point, and that's called the focus, and a fixed line, which is called the directrix. We know this. We went over these. Consider the parabola with a focus point of 1, 1, and the directrix, the horizontal line of y equals -3. What are the coordinates of the vertex of the parabola? Now, we can draw this, but we know that halfway in between the focus and the directrix is going to be the vertex. And we know, well, let me just go ahead and draw it. If our directrix, I'm going to use it as a dotted line at -3. Trying to do a dotted line here. That's our directrix. And the focus is at 1, 1. So it would be this point here at 1, 1. Well, I know that there's going to be a distance of 4 in between here. A distance of 4. If I go from 1 to -3, it's a distance of 4. That means halfway in between that is my directrix. So I can move down. If I divide that by 2, halfway is 2. So if I go down 2 from my focus, I'll be right here, which is the same as going up 2 from the directrix. Therefore, I know that my vertex of my parabola, so it's going to look something like, ooh, missed the line, or missed my vertex. It's going to be something like this. Therefore, my vertex is at 1, -1. Okay, now plot the focus. Oh, okay, well, let's do it here then. So this is the directrix. Here is the focus. Okay, my vertex is here. And, well, get off of that. There we go. There's a rough sketch. Okay, find the equation of the parabola with the focus and the directrix. Okay, so we know that no, I can't, because I don't actually know my y-intercept here. Okay, let's say I could just write the formula with it, but I can't. I'm going to have to do the distance formula. So I know that y equals a -3, right? So if I was to move that to this side, I would have my equation, because it's got to be the same. Y equals, not equals, +3. I'm going to move it. Remember, we just changed the sign, moved it to the other side. And that's going to equal my distance formula here. All right, now what is my distance formula? Well, it's going to be x. What's my x? It's 1 squared plus y. And what is my y? It is 1 as well for my focus. So it's -1 squared. Now, all I have to do is square both sides, which when you square both sides, you got to make sure you put this in parentheses. When you do that, you end up with y plus, I'm going to go ahead and square all of that just to save room here. So I would have y squared plus 6y plus 9 equals, and if I square that, I get rid of my radical. A square root squared gets rid of the radical. So now I'm just dealing with these terms. Okay, what is x? I'm going to go ahead and do my y. I'm not going to do x minus 1 because that's the term I like in my vertex form of a parabola. I like my x minus y, or my x minus 1 squared. So I'm going to leave that as x minus 1 squared. I'm just going to do this one over here. So let's do y squared minus 2y plus 1. I'm going to erase this up here because it's already, and I'm going to show you why I do that. I know we had some questions about this because my form is going to be something like this. Plus k. So I like that. That's going to be the form of this. I like this, which I have right here. So I'm going to leave that. That's exactly what I'm looking for to go in my equation. So that's the reason why we leave that. Now, if I move this to the other side, I get rid of my y squares. Those are going to cancel. So I'm going to subtract y squared from one side. Now, if I add this to the other side, I'm going to get 8y. And I'm going to subtract this and move it over here. So now, I'm just going to rewrite the formula up here. I'm going to have 8y equals x minus 1 squared minus 8 okay. Now, for me to finish this, I'm going to have to do what? I've got to divide by 8 here. So when I divide through everything by 8, I get y equals 1/8 x minus 1 squared minus 1. And that is now my vertex form of a parabola equation. Okay? So that is y equals 1/8 x minus 1 squared minus 1. Okay, what is the y-intercept? Anytime you're finding the y-intercept, x is always 0. So if I plug in 0 for x, I get minus 1 squared, which is 1. Okay, 1 times 1/8 is 1/8. All right, if I plug that in here, I'm going to have 1/8 minus 1. Well, what's 1/8 minus 1? That's going to be a negative 7/8. Okay, which is pretty close to what I had there for my y-intercept. Not really, but okay. Scroll down here. E says, demonstrate that your answer from part D is correct by showing that the y-intercept you identified indeed is equidistant from the focus. Okay, so what that's saying is we're going to have to set these all equal to each other and see if it works out. So let's do that right quick. I'm going to have to erase this again. I do not have enough room here. Okay, so if we're going to demonstrate that the focus, we know that the focus to any point on the parabola is equidistant from that point to the director. So what I mean by that, if this is my, well, let me try and draw it actually like our, something like this. I know that any point from a focus to the directrix is going to be the same. So here to here, this is the exact same A, and let's call this B. A equals B. I know that. That's the whole definition. Even though it doesn't look like it, that is a true statement. Okay? So, now I have to prove that in context of our problem. So, let me do that. Demonstrate your answer. D is correct by showing the y-intercept you identified is equidistant. So, we're looking at the point of the y-intercept. Okay, so the y-intercept is 0, -7/8. And the focus is what? Well, our focus was, it told us 1, 1. Okay, so now let's plug this in. If we get the distance formula, x is going to be, we'll call this x1 is 0. Whoops, I'll put a comma there. Minus 1 squared plus -7/8 minus 1 squared. Okay, if you do that, this is 1 squared minus we'll say plus negative, that's going to be 15/8 squared. Okay, so when we do that, you're going to get, what is 15? 15 squared is 225. Okay. And remember, all this is still square rooted. So we're going to get 1 plus 225 over 64. Okay. So this is we're going to make this 64 over 64. Remember, all this is still square rooted. So that's going to be 289 over 64. All that's still square rooted. And that ends up being 289, square root of that is 17. And over 8. So we're going to have 17/8 is the distance between the focus and, this is the focus, and our y-intercept. That is the distance. Okay, now we're going to have to see what is the distance between the directrix and the y-intercept. Okay, so I'm going to rewrite this up here. That is from the focus to the directrix. So now let's come down here. Erase all of this. And start over. Now we're going to look at our y-intercept and our directrix. Okay? So when you do that, what ends up happening? Both your x's are 0, right? So when we do the distance formula, what is x going to be? X is just going to be 0, right? So then we're going to have -7/8 minus a -3, which is a +3. Okay? Well, what ends up happening is we really are only going to be looking at the distance here. Okay? So, what is the distance between that? Let me make this a little bit plainer maybe. If we have a point that is this point right here, our y-intercept. Well, I can't make it. And we know that this is -3. We're just looking for this distance. Well, it's on a straight line. We're not at an angle or anything like that. So, I can just simply say -7/8 minus -3. Right? That's just finding the distance between this point of -7/8 and -3. So when I do that, it ends up being 2 1/8. Okay, because that's a +3. So we got 2 1/8. Well, that's the exact same as 17 1/8. So I know that those are both the exact distance from the focus to that point on the parabola and the parabola point to the directrix. Right, page 2 says, to the parabola in the question with a focus of 1 1 direction, so we're still talking about the same one, congruent to a parabola with a focus of 2 3 and a directrix of y equals -1. Well, all we're going to have to do is find out what is our distance, or we're going to have to plug in and figure out the formula. Okay. So if we look at a distance, we know that the distance of P is equal to 4. Okay. We know that. And that was the exact same as our other one. So that right there tells us that it is a possibility. Okay. That it is congruent. You know, I said that if it's not the same distance of P, then it's not congruent. But here, it is a possibility because the same is for the other one. So let's look at this. I can plug in let's define the distance formula for this problem. We're going to have y, and since it's -1, we're going to make it +1 equals, the distance formula, 0 minus 2 squared plus y, well, probably shouldn't be putting in zeros, should be putting x's and y's, x, y minus 3 squared. Now we're just going to solve that. And look, we have this, which is what we want, so we're not going to mess with that. So let's square both sides to get rid of this radical. And when we do that, we're left with x squared plus 2x plus 1. And that is equal to x minus 2 squared plus y squared minus 6y plus 9. If I go ahead and do that, okay. First of all, that is y, not x. Sorry. Okay. Once again, those are going to cancel. This is a y, not an x. Sorry. Plus 6y plus 6y. That's perfect because we needed 8y there. If I subtract that, we needed the negative. Oh, that is a positive 8, and that's fine. Okay, so now we have this as our formula. Divide by 8. And now we have y equals 1/8 x minus 2 squared. This is also divided by 8, so plus 1. So we have the same here, therefore it's going to be the exact same distance. Or I'm sorry, it's going to be the exact same distance, but this is going to be congruent. Okay? It's going to be a congruent parabola. Now, is the parabola, if this is G, so yes, it is. Is focus point, the directrix congruent? Okay, so it's the exact same thing. Okay, but let's check our first thing. Is it P? Is it the same distance? Well, if we look with a given equation of y equals x squared, is it the same? Well, no, it's not. Why? Because our other coefficient was 1/8, right? X something, all that was squared, right? What was it? Minus 1. Okay. Well, here we have a 1/8. Here we just have a 1. So that tells you right off the bat that no, that is not a congruent parabola. Now, is it similar? Yes, all parabolas are similar. We can always dilate, translate, and rotate to make them similar. But no, it is not congruent. Okay, H says, are they similar? Yes, I just told you that. Yes, they are always similar. Okay. Now the graph, let's look at number 2. Graph of the polynomial is shown based on the appearance on A. What does the real solution to the equation appear to be? Well, the one real solution is going to be this x-intercept here, which is, well, not that x-intercept, because that's not an x-intercept. Let me try and do that better. That, which is a -2. Okay, that's what it appears to be. Now, is it a real zero? Well, how do we test for real zeros? I can plug this into my formula, and if I get 0, or my equation, and if I get 0, then it is a real solution. So, -2 cubed plus 4 times -2 squared plus 6 times -2 plus 4. Well, this is going to be -8 plus 4 times 4 is 16. This is going to be -12 plus 4. Well, I've got a total of -20 and a total of +20, which is equal to 0. So yes, it checks out that -2 is a factor. Or it's not a factor, it is the real solution. Sorry. All right, write F as a product of a linear factor and a quadratic factor. Okay, so a linear factor means that we have x plus something or minus something. And a quadratic factor would mean we leave it as a x squared factor. So all that means is we're going to take our real solution of -2, we're going to factor it out, and it should leave us with a quadratic solution. Okay, so let's do that. I'm going to erase up here. And I'm going to go ahead and erase this. So we're just going to do long division and solve. So we're going to have x, and remember though, this is going to be +2 Okay, if our real solution is -2, then that's going to be +2. And then we're going to have x cubed plus 4x squared plus 6x plus 4. All right, so we're going to have x squared, that's going to give me x cubed plus 2x squared. Negate those, that gives me 6x squared plus 6x. So I'm going to have plus 6x, that gives me 6x squared plus 12x. And when I negate those, that's going to give me a negative 6x plus 4. Okay. Oh no, let me go back. That's wrong. Okay, let me do that again. When I negated this should have negated as well. It left me with 2x squared plus 6x. Therefore, I'm going to have a 2x, positive 2x. That gives me a positive 2x squared plus 4x. And then when I negate both of those, like I should have done earlier, I would get 2x plus 4, which leaves me with a plus 2. And those are going to cancel everything because when I negate it all, that equals zeros. Okay, so that's going to leave me with an x plus 2 linear factor and a quadratic factor of this. Okay, quadratic because it's squared, linear because it's just, we would write that as x equals a negative 2. So there's the answer to B. I think this, nope, not the last page. Got another one. Okay. So here, what is the value of f of 10? Explain how we know that the linear factor of f establishes that f of 10 is a multiple of 12. Okay. We didn't do a whole lot of these, but we can do that. If we plug in as let me rewrite our factors here. Plus 2. Okay, if we plug in 10 for x, we get 12. That's 100 plus 20 plus 2, which is 22. If we plug in 10 for that, then that's how we would know. We could stop right there and know that it is a multiple of 12 because this right here tells us it is. Now we can multiply that out and that give us 100 or 1,464. And we know that's a multiple of 12 because we just multiplied the number by 12. So, yeah, that's all we need to know. All right. D, find the two complex numbers for y equals alpha of x. Okay, so our complex solutions we know are going to be found in this quadratic here. So let's see if we can solve it. X squared plus 2x. I'm going to move that to the negative 2 over the other side because I can factor out an x now, which would give me x times x plus 2. Okay. And I already had my x plus 2, right? So now I have 2x plus 2. So I could say x plus 2 No, let's not do that. Sorry, let's come back here and let's think of it like this. Let me come back here. I don't want to do this yet. These are our factors. Okay. Now, if we set it up like this, x squared plus 2x plus 1, and now let's move the other one to the other side. Let's do that. Because now I can factor this. Okay? If I factored this, this would be an x plus 1 squared equals 1. I'm sorry, equals our negative 1. Okay. Well, we don't like that because whenever I square root this, I've got our negative, which tells us what our complex number is. We have x plus 1 equals I, and that's plus or minus, remember? Whoops. Because plus or minus always, and we know that I is equal to the square root of negative 1. So x would equal negative 1 plus I, and x would equal negative 1 minus I. Those would be your two. All right, write F as the product of three linear factors. So we'd have x plus 2. And we'd have x plus negative 1 plus I, and x actually that would not be correct, that would be a negative, sorry, minus x minus negative 1 negative I. Okay, and if you just left it there, that would be fine. Or you could go ahead and distribute those negatives right here. But I'm okay with you leaving it just like that. All right, I'm going to pause this or stop this video and do another video for the last few problems.